Find the global extrema of f of x equals x to the 2/3 power times the quantity x minus 1 squared, but only on the interval -1 to 1/2. To find the global extrema, we first make a table of any critical values and the endpoints. The endpoints in this case are x equals -1 and x equals 1/2. We will need to find the critical points. To do that, we differentiate f of x to get f prime of x. In this case, we will have to use the product rule. The derivative of the first factor is 2/3 x to the -1/3 times x minus 1 squared plus, keep the first factor x to the 2/3 times the derivative of the second factor, which is 2 times x minus 1 to the 1 power times the derivative of the inside, which is 1. This is 2/3 x to the -1/3 times x minus 1 squared plus 2 x to the 2/3 times x minus 1. We then set this equal to 0 and solve for x. We will do this by factoring. First, the constant multiple of 2/3 and 2, we will factor out the lowest, which is 2/3. The factor x to the -1/3 and x to the 2/3, we factor out the lowest exponent or power, which is x to the -1/3. Then the factor of x minus 1 squared and x minus 1, we factor out the lowest power. What we end up in the third term is a factor of x minus 1 only. If we have 2x to the 2/3 times x minus 1 and we factor out 2/3 x to the -1/3 x minus 1, the x minus 1 is gone, 2 gone, 1/1/3 is 3, x to the 2/3 minus -1/3 is x to the 3/3, which is 3x. And so for the second term, we would end up with 3x only. Simplifying this, we have 2/3 x to the -1/3 times x minus 1 times x plus 3x is 4x, 4x minus 1. There are three factors here, and this is the zero product, so we would set each of the factor equals to 0 and solve for x. 2/3 x to the -1/3 equals 0, x minus 1 equals 0, and 4x minus 1 equals 0. The first factor is 2/3 x to the 1/3. It will never be 0, but this is undefined when x equals 0. X minus 1 equals 0, so x equals 1. 4x minus 1 equals 0, so 4x equals 1, and x equals 1/4. The 2x value where the derivative is 0 is x equals 1 and x equals 1/4. The x value where the derivative is undefined is when x equals 0. These are the critical points of the function f of x. We then add these critical points to the list of values in the table. They are x equals 0, x equals 1, and x equals 1/4. But our interval is from -1 to 1/2 only. This is the given interval. And so we cannot use x equals 1. We would cross this out because x equals 1 is not in this interval. We then plugged in these numbers, x values, into the function f of x, which is the given function. F of -1 is 4, f of 1 half is roughly 0.16 using the calculator. F of 0 is 0. F of 1 over 4 is roughly 0.22. The largest value from the list is the absolute maximum, and the smallest value is the absolute minimum. And so we end up with a maximum at x equals -1, which is the absolute maximum. And the smallest value is y equals 0. The absolute minimum is at x equals 0. Now, the absolute maximum value has to be the y value or the functional value. It is 4. The absolute minimum value is 0. This is y equals 0 and y equals 4.